You ever just look at your phone or, I don't know, your coffee maker and really think, how in the world did this thing get made? It's definitely not magic, but the process behind it, it's this incredibly detailed, fascinating journey. So today, we're going to pull back that curtain and look at the unseen blueprint that turns a simple idea into the reality we use every single day. All right, so let's ask that question again. How is a modern product really made? You know, we love that story of a genius having a sudden eureka moment in a lab. But the truth? It's way more structured and honestly a lot more interesting than that. It all kicks off with this fundamental challenge that every single engineering project has to conquer. And what's that challenge? Well, it's basically a battle against pure, unadulterated complexity and chaos. I mean, just think about it for a second. Taking an idea from a napkin sketch all the way to a mass-produced item that lands on a store shelf, that involves thousands of tiny decisions, countless variables. Without a solid system in place, it'd be impossible. And that's really what engineering is at its core. It's the discipline of taming that complexity. So how do you actually win this battle against chaos? Well, engineers rely on this time-tested roadmap. And look, this isn't just some list of friendly suggestions. It's a really structured process that gives them a clear path, from a fuzzy concept to a final working product. Let's break down the heart of that process. Okay, so this is the engineering design process. Now, the most crucial thing to get here is that this isn't a simple checklist you just tick off one by one. Nope, it's a cycle. You start with research, right? You got to define the problem. Then you brainstorm a bunch of concepts. After that, a feasibility study checks if your idea is even possible before you dive into the heavy-duty design and production planning. But here's the real secret sauce. Teams might loop back, repeating these steps over and over again, tweaking and refining the idea until it's just right. But, having a brilliant technical design, that's only half the story. Not even. Because if you can't actually build it at a cost that makes sense, well, the whole project is dead in the water before it even starts. And this brings us to the all-important economic reality check. This is what we call economic feasibility. Think about it. Before a company is going to pour millions, maybe even billions into a project, they have to prove that it's not just technically possible, but that it's actually going to be profitable. You can think of it as the ultimate gatekeeper. It's this formal, serious study that decides if the project gets the green light or if it gets shut down for good. So how do they make that huge decision? Well, a lot of the time, it boils down to this deceptively simple little formula. The cost indicator, or CI for short, is just the estimated final cost divided by the target cost. Now that target cost, that's the magic number. It's the price the market is willing to pay for the product to be a hit. And this right here, this is the moment of truth. If your cost indicator is greater than 1, you've got a problem. A big one. Your project is in trouble. It's going to cost more to make than your target price allows. But if it's less than or equal to 1, congratulations, your project is financially viable and you can move forward. It's pretty amazing, right? How this one little number can hold so much power over a project's entire future. Okay, so let's say the design is solid and the numbers work. We're good to go. But wait, how do you make sure that every single component, every little process, and every single person involved is working to the exact same standard of quality and safety? For that, you need a rulebook. This quote really hits the nail on the head. Standards don't stifle creativity. They're the bedrock for safe innovation. At the end of the day, they're just formal documents that define the agreed-upon rules for literally everything, from the specific type of steel you have to use in a bridge to the software protocols inside your phone. They make sure everything works together safely and reliably. And who actually makes these rules? Well, it's this huge global effort. There are hundreds of organizations, like the big ones you see here, ISO, ASME, IEEE, and more, that bring together the top experts from all sorts of industries, whether it's automotive, electronics, or petroleum, to agree on the best and safest way to get things done. Now, having all these standards is great, but they're totally useless if people are working off of old, outdated versions. And that's where document control comes in. It's basically the project's internal library and its rulebook, all rolled into one. It's a system to manage the entire life of a document to prevent catastrophic errors and make sure everyone is, quite literally, on the same page. And this process ensures every single document has a very clear life cycle, from the moment it's created and approved to how it's accessed and who gets it. Every single change is recorded. But what's really important is that when a document is outdated, it's officially retired and archived. This super rigorous system is what prevents a team from accidentally building a multi-million-dollar something based on old, incorrect information. So we've designed it, we've costed it, and we've followed all the rules. The product is finally built. We're done, right? Huh, not so fast. Now comes maybe the most critical quality check of all, which is actually made up of two very distinct and equally important questions.
Imagine this. The product is finally sitting there on the table. It looks right, it feels right, but is it actually right? To answer that, you have to look at it from two totally different angles.
And those two angles are verification and validation. They sound similar, but they're worlds apart. Verification asks the question, did we build the product right? This is all about checking it against the blueprints, the specs. Does it meet every single technical requirement down to the millimeter? But then validation asks a much, much bigger question. Did we build the right product? And this is all about the real world. Does it actually solve the customer's problem? Here's a great way to think about it. You could build a coffee maker that perfectly matches every single blueprint. It passes verification with flying colors. But if it makes terrible, undrinkable coffee, it completely fails validation. A truly successful product has to pass both, no exceptions. So when you step back and look at this entire process, the design steps, the cost checks, all the standards and the testing, it might seem like a whole lot of bureaucracy, right? Red tape. But it's not. This is the essential framework that tames chaos. It's the bridge that allows an incredible, complex idea to safely and reliably become a part of our reality. So the next time you pick up your phone or get in your car, just take a second to think about that invisible blueprint hiding behind it. What everyday object are you going to see differently now, knowing the incredible journey it took to get from just a simple idea to the object right there in your hand?